Welcome to the day in history for April 1st, day 16. Okay, we are going to talk about the day that the comet Hale-Bopp is seen passing at the perihelion. Now, we'll talk more about that word in just a minute. But the big idea for today is that it's not just professionals that can make great discoveries. Okay, I'll write this down so you can, or I'll move out of the way so you can write it down. Okay, now, the orbit of Hale-Bopp was pretty interesting. It comes from below the solar system and then goes back out. So it's not on the same plane as the solar systems or as the planets. All right. Now, it was discovered by these two gentlemen. They were both amateur astronomers who loved looking at the stars, and they had some pretty big telescopes. On the left is Thomas Bopp, and on the right is... wait, for you guys. The guy in the red shirt is Thomas Bopp, and the guy in the dark red jacket is Alan Hale. There we go. These are the two gentlemen that discovered it. They discovered it pretty much at the same time and then checked with each other, and that's why it's named Hale-Bopp. Okay. Now, it was a super bright comet, and that's why we're talking about it today, because it could be classified as what we call a great comet. Now, a great comet is something that is something that humans can see just with their eyes at night and sometimes even in the day. Now, for 18 months, you could go outside and you could look up in the sky, and I remember seeing it because I was a senior in high school. I could see it in the sky. I didn't need a telescope. I didn't need binoculars. I mean, if you had them, it looked better. But everybody could see it. You didn't have to be an astronomer to see this comet. And so, a great comet is one that anybody can see. Now, like I said, the orbit of Hale-Bopp went up and then back through the plane of our solar system. But today is the day that it hit the perihelion, which means it was the closest it came to the sun, which makes it very, very, very bright. Now, this is an extremely bright comet, and we'll talk more about that in a second. Now, what's cool about Hale-Bopp is it has an orbit cycle of about 4,200 years, which means the last time that humans saw this, the pyramids were pretty much brand new, and the epic Gilgamesh was being written. So I'll bet you that the people that saw it 4,200 years ago probably didn't quite understand comets like we do today. Now, this is a good time to talk about how earlier civilizations saw comets. Now, nowadays, we see a comet, and my mind immediately goes to large chunk of ice, outgassing temperatures, solar wind, magnetic fields. Like, I can think and look at the science behind comets and understand what they are. They're still hard to grasp because they're so far away and they're so big, but I can understand it. 4,000 years ago, I highly doubt that anybody was talking about the magnetic fields of comets causing sublimation and the outgassing of particles and stuff like that, right? No. They usually saw it as a sign of good fortune or ill fortune, kind of like the story arcs we talk about. Good fortune, ill fortune. But there are recordings throughout history of these great comets. Now, some of the first recordings come from the ancient Chinese, and this is actually a reproduction of different types of comets recorded on silk in the Han Dynasty, which is about 200 CE, so quite a long time ago. Now, this one, if you remember, this is from 1066. William the Conqueror and Harold II, you remember the arrow that went through the eye? We had that whole discussion about this, and Beatrice brought in the little cards for the tapestry. Well, if you look closely at the tapestry, and this is really cool, look up at the top there, okay? You see how those people are pointing? They're pointing at Halley's Comet. Yeah, Halley's Comet. Isn't that cool? There's literally a great comet on the tapestry from 1066. That's how days in history connect. This is a astronomer's notebook from about the 1500s that's describing the tail of a comet and the comet's orbit. This is another bright comet from the mid-1600s. you can see how it's a really, really bright object in the sky. Can you imagine now why people saw this as a good omen or a bad omen? Say you were a king that was preparing for a giant battle in, say, France or something, then all of a sudden this comet shows up in the sky. You would think that it was a sign from the heavens. A lot of people did. Now, one of the brightest comets in history is the Great Comet of 1811. This was a very, very bright comet, and I believe last year we actually did a day in history on this one, but this is a pretty famous picture of that comet. Now, nowadays, we don't use pictures like those last ones we looked at, but we look at data. Now, this is a print or a printout from the Jet Propulsion Laboratory, and it tracks all the different sightings throughout history of comets and their relative brightness. Now, 1.0 is like super bright, and like 0.05 is like not very bright at all. Now, the Great Comet of 1811, the one we just saw, was 1.04 brightness. Hale-Bopp was 0.91. So Hale-Bopp was very, very, very bright. Now, we know nowadays that comets aren't these religious signs that just show up in the sky. They're actually large chunks of rubble, ice, rocks, and dust that come from a place called the Oort cloud, or the cometary nuclei outside our solar system. If you look at this map here, the sun in the very middle is surrounded by the solar system, what comes out a little bit, but the Oort cloud is like this giant sphere around our solar system that has all kinds of remnants or things left over from the formation of our solar system. Now, we know that comets today look like this. They're not bright, shiny puffs of puffballs or whatever you want to call them. They look pretty much just like asteroids. Now, it's this that gives it that puffball, that tail sort of look. Now, what happens is when the comet gets closer to the sun, it starts to heat up a little bit, and it starts to interact with the magnetic field of the sun. We'll talk more about that in a second. But it creates something called sublimation, which is when the gases below the surface start to heat up and they release a gas into space, which forms a cloud. Now, Hale-Bopp is a really good example of the two types of tails on a comet. Now, one side is actually the dust, and that's the white side that you can see over here. Now, that's the dust and the little rocks and some of the gases coming off. But the blue side is actually what we call ionized particles, which is a different type of tail that has to do with atoms losing electrons. Now, here's a little diagram of how a comet works. Now, in the middle is a nucleus, which is the actual comet itself. It's made up of all kinds of different things, ice, carbon dioxide, all kinds of things. Now, as it heads towards the sun, pulled by gravity, the tail starts to form opposite the sun. And it has to do with not only the heat produced by the sun, but the magnetic field and the solar wind. Okay, so if we look at an atom, now when the solar wind comes out, it actually has ionized particles, or particles that have a charge that's like negative or positive. Now, when those charges hit the atoms on the comet, they break off some of those electrons, and those electrons are what we saw in the blue cloud. And then the heat from the sun, which causes the ice to heat up and shoot out in gases, that's what causes the dust and the other particles to come out for the white cloud. We could talk a lot more about how the tails are formed, but that's a little short version. Now, the last thing I want to show you is a NASA probe called the Stardust. Now, this was launched in, I think, 2004, and it was pretty small. And this picture here is about the size of a tennis racket. And it's this special kind of gel If you've ever seen like the shows where they shoot a bullet at like gel to see how far it goes in, this is that same sort of stuff. And if you look over here, you can see that they actually took this probe and they went through the tail of a cloud of a comet, and they caught some of the stardust particles. And you know what they found? They found amino acids, carbon-based amino acids, which is the same things that we have in our bodies that create proteins. It's the same thing that most of all of life on Earth shares, are these amino acids. And it reinforces the scientific notion that it's probably these comets that early on in our solar system brought these proteins and these amino acids to Earth that eventually changed into us. We are literally stardust. See you guys tomorrow.